Hey guys, I hope that I'm live right now. If someone has, if everyone is able to hear me and watch me clearly, just let me know in the live chat so that I can get an idea about it. Okay. Yesterday I was not able to take a class due to some work that I had in the office, so I had to complete it. But from today it will be regular. I'm very sorry if anyone faced any problems due to that yesterday. Okay. We'll get started right away. I will just wait for 5 more minutes. If someone is not joining us right now, he or she can. Yeah, you can listen. That's great. Also, I saw one of the questions that are we going to provide the certificates, or is this all fake and a hoax? So let me just show you that I can, because we ask our students who are getting the certificates to post it on LinkedIn. One of the main reasons that we do so is because many recruiters, when they see that you guys have got these certificates, they tend to contact you. Like, they understand that you do know machine learning, you do know other stuffs like deep learning and computer vision as well. So there are many instances where we have seen that, and we want to continue with that itself. Just let me show you to just prove you that yes, certificates are being given out, but like I said, only to those people who actually get 100% attendance, as well as many other things as well, like the project submission and all those kind of stuff. We look into it. So this is the certificate for the project completion. So it is given by ASC, that is AWS Students Club. The another certificate that is being given by Shape AI, let me just scroll, it would be right over here. So this is a participation certificate that was given by Shape AI. So yes, though, and this is in collaboration with Microsoft Students Learn as well as AWS Students Club. So this is given on the basis of attendance, 100% attendance. So that is the thing, like yes, you will get the certificate, but you will also have to do the entire work as well. It is not just that without even attending the classes you will be able to get this certificate. Okay. Yeah, for those who were late in the registration process, or there were many other factors which we took into account, so due to that many students might not have got the registration certificate. Most of the reasons were either the application that they submitted was bogus, or the second reason was that they were actually late for submission of the registration form. So this is the certificate of appreciation that was given out in the beginning with the final registration itself. So that's the thing. Okay, moving forward to other questions. So this mouse is being a very problematic thing for me. Okay. So okay. Yeah. Yes, yesterday's class is going to happen today itself, so I've just like rescheduled it. Okay. uh, PPT. Yes, the PPT will be shared. I will ensure that today itself the PPTs that I'm using will be shared on all the WhatsApp groups and Telegram channel. So you don't have to worry about it. Today by 12 midnight, all the PPTs that I am currently using, that will be shared on all the WhatsApp groups as well as on the Telegram channel. So from there you can access that as well. Okay. Yes, every month we have planned to conduct 3 boot camps like this. The 3 topics of the boot camps will most probably be one on web development. That will be React.js, Node.js, JavaScript, HTML, CSS, SAS, Dockerization, Kubernetes, all these kind of technologies. The second one will be on like data analysis, machine learning, machine learning, computer vision, NLP, And there will be a third boot camp on data structures and algorithms, competitive programming, arrays, linked lists, dynamic programming, and many other topics. So every month for the entire year, we are having 3 boot camps. But of course, these boot camps are of a very beginner level. So for those trying to understand a particular topic, trying to get into a particular industry, and they have no prior knowledge about these topics, these boot camps are focused upon them itself. Okay, it is not for someone who thinks he knows stuff. We want our students to join us only if they think they do not know anything, so that we can mold them according to us. Okay, so this is just for those people. This is very basic concepts. Each boot camp will have its own associated project. So every boot camp except the except the data structures and algorithms, that is web development and data analysis, will have a project associated with it at the end of the boot camp. Of course, these projects are not going to be a very large project, but enough so that you can put it on your resume. Okay, so that's the thing. Okay. Yes, the every boot camp that we organize, early on it was of 15 to 17 days, but now we have like shortened the duration of the boot camp to about 7 to 8 days itself. There is no problem if someone has not received the final registration certificate. There is no problem with it. Okay, if you still have like attendance as well as attendance as well as the project submission, you will still get the rest of the certificates itself. One of the person has written Hindi mein bol. So I would like you guys to know that we have students from Spain, we have students from Italy, we have students from US, we have students from Dubai, we have students from Indonesia. So we are having so many students from different countries joining us for these boot camps. Hence, the language that we are using in the boot camp is English itself. Many South Indian people are also joining for the boot camp, and they do not understand Hindi to a very good level. So English is a language that can be easily understood by almost 80% of our population, educated population in India. So that's the thing. We have selected that itself. Okay. Yeah, we have people from Nigeria as well. Shout out to them. Okay. So let's start with today's lesson. I will be sending all the PDFs that I have used till today on all the WhatsApp groups as well as the Telegram channel by 12 midnight tonight itself. Okay, so there will be no problem associated with it, and let's just start. And from today, I'm not going to focus a lot upon the live chat because I usually get distracted because people don't know how to talk in the live chat itself. So you are on a social platform, guys. Please maintain the decorum of that as well. Okay, I know you think that it's social media and nobody will know who I am or all this kind of stuff, but you don't know that Facebook's API allows us to get your email, and from your email we can figure out who you are. So just try to we are not saying that, but just try to understand that you are not invincible. This is internet, it's open to everyone. So try to maintain the decorum of the class, and let's get started right away. So from today we will be starting with computer vision, a very important topic, like the main topic that you are in fact here for. So I guess I am having a bit of charge issue with my iPad. Okay, so no issue for that. If it dies, it dies. Okay, I will just connect it to my laptop and then we will get started right away. Okay, mechanical engineers. So till the time it is opening, I would like to answer this question. Like, of course, machine learning and AI is like used everywhere, literally everywhere. Whether you be a chemical engineer or a mechanical engineer. So one example for a mechanical engineer student I would like to give, in like the last bootcamp also I gave this exam. So there is a car, okay, that is being designed, that is being manufactured, that is being assembled by an AI itself. There is no designers on the team, there is no manufacturing workers on the team. A single person makes one car using the AI in 13 days. One car by just one person. He is the person who is designing it, he is the person who is manufacturing it, he is the person who is assembling the entire car. And the best part about it is being coined. The car, as it is designed by an AI, as it is manufactured by an AI, and as it is assembled by an AI, it is deemed as the most efficient car of the entire century. Okay, you can Google about it. I don't remember exactly its name, but you can Google about it. So that's the beauty of in mechanical engineering. Okay, in for example, Audi and all these kind of plants are there. They require so much space, so much man force to just assemble a single car. And this particular car that is being designed, manufactured and assembled, so the manufacturing is happening using an AI working with a 3D printer. So the entire car is being printed, so it is being 3D printed, but it is using metals itself. Don't think that okay, 3D printer can only print like plastic and all those kind of stuff. It can print metal objects as well. Okay, it uses some kind of dust and it just squeezes them together. So you can read about it, very interesting. So that is where mechanical engineering. Then for pharmacy, drugs, of course, like it takes about 10 years to develop a single drug that can be fast forwarded into just 1 year using a lot of computational power and AI. That is being done right now. The entire 10 years shrunken into just one. No need of any animals, no need of any human beings to test the drug upon. Okay, then in chemical engineering there is a lot of like thermodynamics, the plants and everything has to be maintained. So chemical engineering, don't think it about like being biology and all those kind of stuff. You don't have to mix chemicals always. There is like major part of the chemical engineering is just thermodynamics. So the entire plant, how can it be made more efficient, so it is also producing data every single time it is working. So that data is being used and fed it into a machine learning model that gives out the best modeling for the entire plant, the entire schematics for the plant being developed just by a machine learning algorithm. So machine learning and AI is being used every single way, whether it be chemical engineering, mechanical engineering, and so on and so forth. It's just that you need to figure out your own idea if you want to succeed in this field. Okay, that's the main thing. If you want to do something big, something huge, then this is something that you can. One other example that I would like you to like, I would like just like you to know, shoes. So basic, right? Like you need an artist, the artist will make a sketch of the shoe and just use the shoe to make a shoe. Basically that's the entire process. Nike has been following this process for thousands of like not thousands of years, but for like almost like a decade or so, and it is being a very successful brand. Now the entire process of making a shoe can be done by an AI from the designing itself, that too like of your standard itself. You, it will take the footprint, okay, it will take the user's footprint and it will design a custom shoe according to his or her likes, his or her standards, his or her shoe print. Okay, so what material should be used for his weight, what material should be used for his like size of the entire foot, all these things taken into consideration, it is able to manufacture an entire 3D printed shoe. So that's the beauty of AI. Like the entire process of the entire organization like Nike being done just by an AI and a 3D printer and nothing else. Okay, and a scanner as well, because you have to scan your foot as well. So that's the thing. Okay, so let's get started with neural networks. Enough of the examples. Neural networks or CNNs, convolutional neural networks. This is what we will be discussing today. Okay, very important topic, very easy to understand topic. Just pay a lot of focus upon what we are going to learn today. There will be a lot of words that I'm going to use today. Okay, I will be explaining each and every word, but you need to understand the theory behind it. Otherwise, while writing the code, you will say that what is happening right over here, I'm not able to understand how this code is actually functioning. Okay, so let's get started. How a digital device sees an image. So when we are seeing an image, for example, the screen that you are seeing right now where I'm teaching, you are able to perceive the entire screen in terms of just a picture. You cannot explain, like if I'm asking you like how is your brain seeing that picture, you're not able to explain it to me. Like I can just see a picture that happens naturally. How can I explain that thing to you? Okay, but the case is very different with computers. computers can only understand binary language at its most core basics. Like if I'm going into like extreme low level, then it's just ones and zeros and nothing else. Okay, but when we are inputting an image to a particular computer, how is that image interpreting the computer is fairly simple. It sees the entire image in terms of numbers. Okay, you must be familiar with this particular term, that images are actually made up of pixels. Okay, your screen is made up of pixels and image is also made up of pixels. You have 4K, that is like 8,000 some, sorry, 3,000 something pixels. You have 1080p, that is 1080 pixels, and so on and so forth. So images are usually coined in terms of pixels. Now for example, this is an image. Okay, so the entire image will be represented in terms of a matrix. Okay, so these are the matrix, and each unit, for example this particular box that I'm shading right over here, okay, this is called as a pixel. This is called as a pixel. Each pixel has a value between 0 and 255. So each pixel present in the image has a value. I'm talking about black and white picture right now. We'll talk about how do the like computers perceive a like colored image. Right now I'm talking about black and white pictures. So each pixel, so you are having a picture, for example this is the picture actually. Okay, so when I'm like making a rectangular box around it and I start to divide it, okay, I'm starting to divide it. As I'm able to scroll, okay, you are able to see that some boxes, when you scroll sometimes some boxes appear around the entire edges. Okay, so you are having this particular, let's just take up a black line of a thickness. So this is a zoomed image of this particular line. Okay, this entire line I have zoomed it right over here. So how will, when we are zooming it in, how will we see this particular, like how will the computer see this? Okay, it will first, okay, sorry, it will first form boxes around it. Okay, so it will form boxes around it, and each of this box will contain a particular color. Okay, so this contains black, this box 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 contains black, and this box also contains black, for example. I'm just zooming it a lot. Okay, I'm zooming it thousands of times. Okay, then this is how it actually looks like. Okay, the actual image looks like when zoomed in. These all empty white boxes will contain value 0. Okay, these boxes will contain value 0. The boxes which I have shaded red will contain, as it is pitch black, it will contain 255 as the value. Now of course, as you are able to see, for example if I'm looking at this particular area, okay, let's just color it into some other way. Let's take up gray. So this area, okay, this area is black, but it is half white and half black, something like that. So what will happen is that would be a shade of gray. Okay, that will be a value that is in between 0 and 255, a value in between that. And this is how, when you zoom in a particular image and it starts appearing like boxes, some of them are black, some of them are a little bit gray, and so on and so forth. When you enhance a particular image, so for example some of you must have iPhones. Okay, iPhones are known for their like excellent picture quality, but when you zoom in the pictures, the image starts like, in Hindi we call it as phat jati hai image. That is, the image gets torn apart. Okay, we are able to see the pixels in the image, we are able to see the boxes, and each box, if it was a black and white color, would have like either it would be pure white, or it would be pure black, or something in the middle like a grayish hue color would be there. Okay, so that is how a particular computer sees an image in terms of 0 to 255, a number between them which represents its shade of gray. Okay, so that is very important. So it looks like a 2D matrix. I hope that you are able to understand this. This is very important to understand how a device looks at a black and white image. Of course, I am repeating again that we will be talking about colored images as well. Currently, I'm not talking about it because I don't want you to confuse yourself while moving further, because we have to discuss a lot of things and I really don't want you to get confused. Okay, so I will just see the live chat so that I'm able to understand that you guys are able to understand. So if you are able to understand, just write yes on the live chat so that I'm able to understand that most people are like paying attention at least. Okay, I'm not able to open the live chat. Yes. So just a single person understood the entire thing. Okay. That's great. That's great. That means that I'm able to make you understand this. Okay, why am I not able to see a gray colored image when I'm scrolling into this? Because this is a vector image. Okay, vector images have that capability that no matter how much you scroll into it, it will get adjusted into such a way that you're not able to see the pixels. That is called as vector images. This is the type of images that are being used by companies when they are making their billboards, when they are making their posters, because the image is very small. You have to scale it to a very large extent. Hence they use vectors of that, because the image on your laptop, for example, is this much, okay, but on a billboard it's like a huge image. So to scale that much, it will bring up the boxes and we don't want that. Hence you use vectors. As this is a Canva image, it is a vector, so vectors have that particular property. We'll look at it in the next slide. See, right over here, when I'm not even scrolling, you can able to see that this particular one, okay, when zoomed in, you are able to see right over here there is a gray hue. Are you able to see this? This is a gray color, okay, this is black, this is white. So the value so here what I've done is, instead of having values from 0 to 255, I have divided everything by 255. Okay, so the values of this particular pixel, I have represented it as between 0 and 1. Are you guys able to understand? Okay, so Akshat Bhagat has asked a very, like, I don't even want to answer that. Okay, so moving forward, are you guys able to understand this? Like, what I've done for this representation of this is, you are having 0 to 255. Okay, I've told you each pixel has 0 to 255 value. I've just divided it by 255 for making this representation so that it does not like go beyond that. Okay, so an interesting question has been asked by Krito. Krito has asked, so the whole system crashes if the value goes beyond 255, for example, 256. If you guys follow unbox therapy and all these kind of different Mr. Who's the Boss, these YouTube channels, these are tech based YouTube channels. On that, a few months ago, like almost like a lot of months ago, there was a particular video. You can go back and check it. It was about a wallpaper. Whenever you were installing that wallpaper on your mobile phone, the entire mobile phone was crashing down. Okay, Mr. Who's the Boss? Yeah, Mr. Who's the Boss. I guess like that was the video. Okay, so I also researched about it. Like, man, what can be the issue behind it? And I also came up to the same conclusion that Mr. Who's the Boss told us. Okay, so basically, what he told us was that different pictures have different encoding standards. Okay, so what I'm currently telling you, this encoding standard of 0 to 255, this is the universal standard, and this can be easily used by any item, whether it be a phone, laptop, or many other things. But sometimes there are some type of pictures which can, there are some like formats of pictures which can have values from 0 to 258 or something like that. Okay, so not a lot of difference, but they can take up a like more number of colors. That is basically possible. Okay, so that's the basic problem that occurred with that wallpaper. The wallpaper was of a very different what can I say, format. Okay, that took in 0 to 258. So that particular wallpaper took in 256 as an input for one of those boxes, and hence the entire system crashes. Okay, so this is what happened. Okay, so yeah. Okay, so let's start with this entire thing. I just went off track, but this is also very important. A very nice question, very important to understand this as well. Okay, so here so if I'm feeding this particular box to the computer, it will crash because it does not know what this is. I have to multiply the entire matrix by 255 and then pass it on. Okay, so that is also something that you need to understand. So for here, you are able to see 111 up till here. Okay, so this is 1 1 1 1 1 1 1 1, and this is the area where the entire thing was black, as you are able to see this entire area, which is exactly black on the entire thing. Okay, that has been termed as 1. Okay, that is 255, because 1 into 255, 255, and the rest of the area, so this is like it is fading away. So 0 0.9, 0 0.3, you are having 1 right over here as well, so this is also 1. Okay, then you are having like it is decreasing right over here. This is gray, this is also decreasing here and here. So this is how a computer interprets a black and white image. We'll look at colored image later on today itself, but this is something that is very important for you. Okay, next. So this is an example of an image. So this is a 28 by 28 image, that is 784 pixels are there, and here I have put it up in 0 to 255. So this is how a computer, if fed this image, will interpret the entire image. I will just zoom in a little bit. As you are able to see, this is an inverted image, so that you are able to see it very clearly. It is inverted in color. Okay, so where there is white, think of it as the black, and so this is just a normal inversion. Okay, uh, as you are able to see right over here, this is the 8 that was being made by the entire picture. So this 8 got converted into this entire thing. Okay, so this is how an entire image is being understood by the computer. Okay, 0 to 255 are the numbers. Are you able to see this? 0, then 61, 242, 208, 1113. So these are the numbers. Okay, now when you are dealing with deep learning, coming back to machine learning and deep learning, so you need data to process, like to make like entire, you are working basically on data. So this data, that is images, will be fed to your particular neural network. If you don't know how the entire image is being represented, then how will you feed it to the entire neural network? This cannot be fed in a single manner. Okay, this is the image, just like take it in. This is not what happens. Okay, so there is a lot of different levels on which you need to understand the entire thing, and hence we are discussing about the entire matrix. I will just close the live chat. Yeah, now this, for example, this is our neural hidden layer. Okay, so this is our hidden layer. We discussed about hidden layers. This is our input layers. So this is how it is being like taken in. So this entire matrix, what we'll do is we'll flatten the entire matrix. What do I mean by flatten? The entire row, this entire row, okay, this first row. So this is the first row, the second row, and so on and so forth. Normal like 0, 1, 2, I'm just labeling it. So I'll just take off this particular entire first row. Okay, I'll just take out the entire first row, so it will look like 0 0 0 0 0 0 0 0 and so on and so forth, 0 0. Okay, then I will take out the second row as well. So that is the second row. Let's just take another color. I will just take out the second row as well. This is the second row, and then what I will do is, this is the first row, this is the second row. I will just take it out, I will bring it here and I will attach them. I will just append them. So this is the first row that is in black, as you are able to see. This is the first row that is present right over there. We'll just take out the second row and I will attach it to the end of the first row like this. And so on and so forth. So for all the rows, I will do the exact same thing. Now, instead of all the rows being stacked one below the other, every row will be attached one after the another like this. Okay, and hence the entire input would look like a single array. The entire input would look like a single array of 784 pixels. That is the total number of boxes that is present in this entire two-dimensional matrix. So all the boxes are now present in a single array, one-dimensional array, that will then be fed to the hidden layer as an input. So this is actually how we convert by the term flatten. Okay, the flatten is an actual function that is present in Python. We will be looking at that as well in the when we will be writing the code. Okay, so that is a function that takes in the matrix. Okay, it breaks all the rows down and then it attaches the row one after the another. Okay, so for example, this is the entire thing. So it will just take out the row below it, it will attach it right over here. Then the next row it will take out and attach next to it, and so on and so forth. Very simple concept to understand, nothing new in this. Okay, if you are still not able to understand, just let me know, or better don't let me know. Okay. Okay, so I think so there must be a mistake on my end. Someone said that 0 is actually black and 255 is actually white. It may be possible that I am wrong in this. I don't remember exactly correctly, but I will look into it and I will come back to you tomorrow. It may be possible that I am wrong with this. Okay, it may be possible that 0 is actually black and 255 is white. So very short difference between them. You just like look into it on the net and you will get to know about it. Okay. No, it does not depict different colors. I've already said 0 to 255 in black and white only. Okay. Okay, so yeah, so someone has said that they have checked on the net. Okay, so 0 is black and 255 is white. Okay, just try to remember that 0 is black and 255 is white. Okay, are only 784 pixels for all 2D images? No, this is an image of 28 by 28 pixels and hence it is 784 pixels. Okay, it has 724 pixels. Okay. Different colors, I have already said that I will be talking about it later on, like towards the end of the entire class. Okay. So I hope that you have understood this. Very simple. All the rows are being popped out. So all the rows are being taken out and it is being attached. So this entire a single row of 784 pixels will then act as your input to the entire neural network. Okay. So yeah, that will be something that is very important. Moving further. Okay, so now we'll be discussing about how do okay uh, okay, so we will now be discussing about how do the entire convolutional neural networks came into being, like what was the concept behind it and everything. So IBM's Deep Blue supercomputers, that was the first supercomputer, that was not the first supercomputer but the main supercomputer that is being discussed, IBM. Okay, IBM Deep Blue. So this was one of the main supercomputers in, I guess, 1996, that was able to beat a particular grandmaster in chess. Okay, so that was the first supercomputer. So at that particular point of time, like the main problem was you needed a supercomputer to run even the basic deep learning networks itself. Like you needed a supercomputer. Now not everyone has that kind of like resources available to buy an entire supercomputer of billions of dollars. Okay, not even millions, billion. So that's biggest problem that was faced back then, because development was very slow. But still, like I've already said, that most AI is being developed by looking at what humans do. Now, one of the main things, one of the main researches that was going around 1980 was to understand how humans perceived a particular picture. Okay, if a picture is being shown to a particular human, how will that human look into it? At that point of time, we knew that human brain consists of neurons, but how do they function properly? That was one of the main questions that the researchers at that point of time, neural researchers, wanted to know the answer to. Okay, so for example, we take in a particular picture. So this is a particular picture of a house. It is very crudely drawn. Okay, so this is a particular picture of a house. Now you are having an eye. Okay, so the eye perceives the picture. Okay, this entire picture is being perceived by the eye. So what did these researchers do? So like it is called as the brain's visual cortex. Okay, so this is called as a brain's visual cortex. So in the brain, there is an entire area dedicated just so that you, whatever you are seeing, it is being interpreted by your brain. Okay, so that is being done at the brain's visual cortex. Now, they have been like these people, okay, these researchers tried to understand how our brain visual cortex actually worked, okay, so that we can remodel it using deep learning. That was their main goal. So what did they found out was, for example, these are the neurons, okay, the neurons in your brain that got the first information of the data from, okay, so let's just take another color that we are able to see it much more properly. Okay, so this new are the neurons in the brain's visual cortex that got the information from your eye. Okay, the first neurons that got the information. Of course, not all the neurons present in your brain's visual cortex got the information at the same point of time. There was some like neurons that got the information first, and then they passed on to the rest of the neurons. Okay, so for example, what they found out was that these initial what can we say, neurons got information about very basic things. They did not got the information about the entire picture at one time. That is, this neuron did not get the picture of the entire house. Okay, it just focused upon a very small piece of the picture. For example, this neuron focused just upon this particular area. This neuron focused just upon this particular area. This neuron focused just upon let's say this particular area, and the last neuron focused upon the door itself. So each neuron was focusing just on a very small area of the entire picture, not the entire picture itself. When these neurons then like shared the information that they got with the next neurons, okay, the neurons which were present on a higher level, they received the information from some of the neurons. Okay, so this got information from here and here and here. This got information from here and here and here, for example. So not all the neurons present in the entire brain got all the information from these initial receptors, but only some of them got it from some of the receptors. Now, what did the initial receptors see? The initial receptors focus mainly on lines. Okay, so for example, like a slant line, a horizontal line, sorry, a vertical line, a horizontal line, a small curve. Okay, so these initial receptors looked at these small details, only a small part of the entire picture. Okay, the next neurons took in these features. So these are called as features. Okay, these are called as the features that they got from it. Okay, these lines. Then these neurons, these next layer of neurons got these features as input. Basically, they did not got the picture as input. They got these learned features as input, and from these features they took in some. For example, this particular neuron got information from the first one, the second last one, and the last one. Okay, these three features it got. So it got this and this feature as its input. Okay, and from this it was able to find out, for example, a feature like this. Okay, it saw complex feature like this. Okay, the next neuron saw a complex feature like this. The next neuron saw a complex feature like this, and so on and so forth. So these initial, so the initial neurons got like very basic inputs, whereas the next set of neurons got inputs that were a lot difficult to understand. Okay, some complex patterns, some complex like shapes, they were basically shapes they were able to figure out. The next, now these neurons itself are connected to several other neurons as well. Now those neurons, these new neurons that are present at a very high level, they look for high level features as well, not easy to figure out. High level features. Okay, now these features are what basically comprises of the entire house itself. So these may be, for example, these are able to see a particular house type of structure. The next neuron is able to see an entire door. Okay, using these features as an input, these complex shapes as an input, they are able to find some other patterns, some other like portions that they can then classify into, okay, this is taking a shape of a house. This is how our brain functions. Okay, this is actually how it functions. Now this is, they did this by a very complicated methods. I'm not a biologist, I cannot like say what was their process, but this was the entire research that they did. This research got them a Nobel Prize after 20 years. So this happened about 1960s, 1959, and they got the Nobel Prize around 1981. Okay, so this particular study got them the entire Nobel Prize, and also inspired Jan LeCun and other computer scientists to develop the first CNNs. And the first CNN that was being used by like millions of people was the text classification. Okay, the number classification, MNIST dataset. Okay, that you will be very familiar with in a few days. MNIST dataset, that is what they used, and this dataset was being used by like banks to figure out like whether you have written the correct number or not on your particular like check. Okay, so that was the first major like use of this particular CNNs, and it was called as LeNet, I guess. It's called as LeNet 5 or something like that. Just do check it out. I don't remember the exact spelling, but it was called something like that and were developed by Jan LeCun. Okay, one of the biggest pioneers in deep learning and computer vision. So that's also something that you need to know. Moving on, let's see at the components that we are going to use while making our very own project. Okay, these components are something that you need to understand how they work, otherwise you will not be able to understand the project at all. Okay, so that is something that I will be focusing upon right now. Yeah, Krito, I also agree. The 0 is for black and 255 is for white. Okay, yeah. Yes, this, as I've already said, the project is something that you can directly use on your resumes. So that's the thing. Okay, people have understood what I'm teaching, so that's okay. I'm keeping it very basic because this is something that I have learned almost 3-4 years back. This is, I'm just like revisiting my notes and just making this up for you guys. Like, of course, I'm not working upon this. I'm actually a data analyst, so I'm working upon much more greater problems rather than just making convolutional layers. But still, like for you guys, because I understand 3,000 people coming to this boot camp, I know that 99% of them not even know what machine learning is. So I have to keep everything very basic so that people are able to understand, people are able to relate, and like then only they will be able to understand it. Machine learning is a particular field, computer science is a particular field that if you don't have interest in it, then it will be very best for your sake itself to be out of computer science itself. Otherwise, you will never be able to get a single job in computer science. Even if you are managing to get a job, that will be a very low paying job. So that's the thing. You need to love it. You need to understand it. You need to feel the essence for the entire subject. Then only you will be able to like grow in it basically. Okay, so moving on to convolutional neural nets. What this is something that we are going to use a lot, so it is very important for you. Uh, Okay. Yes, today also there is just theory. If I'm able to complete the theory for like computer science, computer vision today itself, then from tomorrow we will be starting with the Python. Okay, we'll start with Python programming. If it is not being completed today, the theory, then tomorrow also there will be theory itself, and then from day after tomorrow we'll be starting with Python programming. Python programming will take out for at least 2 days, I guess, and then we'll be getting started with the entire computer vision projects. No, computer graphics and algorithms, it is not being used in computer vision in the very basic like steps. Okay. In the later on steps, of course, for example, when you are on a very good level, when you are doing research and everything becomes interrelated in computer science. Okay, so that's is something that you need to know. We will not be dealing with RNNs. We will have a separate bootcamp on RNNs as well. And this we are just going to deal with CNNs itself. Like I've already said, TensorFlow and the entire project itself will be dealt in the last 2 days. Okay, project itself will be done in the last 2 days. No, computer vision is not just about deep learning, but yes, 99% of the projects are using like deep learning itself for computer vision basic steps as well. I personally use like HP Pavilion i7 8th gen GeForce, I guess, and for the another work related stuff, I use MacBook Pro M1 chip. So that's the thing. But whatever like laptop that you are getting, just ensure that it is having a good RAM. Okay, so let's get started. For cyber people, it is not useful, I guess. Like deep learning is something that you can use, but like not computer vision. Okay, so let's move on with convolutional layers. Okay, so convolutional layer, one of the very important topics to know and understand. Okay, I was using white, so it is very important for us to know what convolutional layer is, and on the basis of that we'll be moving forward. So this is your input layer. Okay, this is your input image. Okay, this is the image that is being inputted to the entire model. Okay, so this entire thing, as you are able to see, these convolutional layers, what they are doing is they are acting as these layers. Okay, these layers of neurons that were present. Okay, think of them as the convolutional layers. They are not looking at the entire picture, they are looking at just a part of that particular picture. Okay, in a similar way, the first convolutional layer is just like this first layer of neurons. It is not looking at the entire picture, it is looking only this particular neuron. So this is a neuron, for example, right over here, this is a neuron. It is not looking at the entire picture, it is looking only at a part of the picture. Okay, this particular neuron is not looking at the entire picture, it is looking only at a particular part of that particular picture. Okay, that's all it's looking. These neurons are then making these features are being made. Okay, these are all features that are present, and these features, the neuron in the next particular convolutional layer is only looking at some of those features. Okay, these neurons, whatever like patterns have been found by the neurons present in this particular area, only these features are being seen by this particular neuron. So that is the entire concept of convolutional layer on a very high level. Okay, let's try to first read through what I have written right now. Okay, neurons is the first convolutional layers and are not connected to every single pixel in the input image, but only to pixels in their respective fields. Okay, like I've already said, this is a particular field. Okay, so this neuron will be connected to each and every what can we say, each and every pixel, or each and every image or neurons. So for example, for this particular neuron it will be each and every neuron, and for this particular neuron it will be each and every pixel. So it is being connected to only those images or pixels or neurons that are present in its own field, okay, not the entire picture or not the entire feature set. Okay, in turn, each neuron in the second convolutional layer is only connected to neurons located within a small rectangle in the first layer. We have already seen that. This architecture allows network to concentrate on small low level features in the first hidden layer and then assemble them into high level features in the next layer, and so on. That is what we looked at here. We got some small low level features from the first convolutional layer. When we moved above, the hidden layers got more complicated, and they were able to figure like much more complicated and high level features from these low level features itself. The same thing happens. These neurons figure out many different, this layer of neurons figure out many different features, low level features, lines, curves. These can be horizontal, vertical, and those features that are being found by these neurons are then being used by this particular neuron in the second hidden layer, in the second convolutional layer, to find much more higher level complexities and higher level patterns, high level features are being able to found. Okay, this hierarchical structure is common in real world images, which is one of the reasons why CNNs work so well for image recognition. So this is what I have already explained. Like the entire concept of CNNs was what our human body does, what our human eye, what our human brain's visual cortex does. So that is the entire thing that has been implemented here. So each layer of these neurons is now called as convolutional layers. Okay, just remember that, that is the entire basic. So these layers have now been named. The name of these layers are convolutional layers. Okay, so now how does a convolutional layer actually like work? So this was a high level overview. We'll now look at what are the different functions. Okay, so let's, okay, this is a particular okay, so what happens right now is you are having this particular picture. Okay, now this is a particular picture that we are having. Let's just color it right over here. Okay, so this is a particular picture that we are having. Of course, this picture can be divided into rectangles. Okay, so we have divided the, okay, let's just make a particular easy picture so that I'm able to make you understand the entire concept. Just increase the pen size. A simple to understand picture of let's take up 4 by 4 pixels, that is 16 pixels are there in the okay, so there are more than 20 pixels for now. Okay, so what will a particular the next, so this is the image. Okay, and so for example this is the image. Okay, so just compare this with this, and this is the convolutional layer. Okay, so for the convolutional layer, what it will do is it will take the first 4 boxes, for example. Okay, it takes the first 4 boxes with it. It performs some type of computation. We'll look at what the computation is performs some type of computation and converts these 4 boxes into a single box. Okay, then it will move forward. Now how does the entire box move forward? The entire, like whatever the first convolutional layer was looking at, it will move forward, and that moving forward is called as a stride. Okay, Pranshu, just bring me the charger for the laptop, sorry, for the tablet. So basically it moves forward. Okay, now that is called as a stride, and we will look at stride when we are coding. So that is also a terminology that you need to know. Now the box can move forward by one particular block, the block can move forward by 2 particular blocks. Just attach it right over there. Okay, and so on and so forth. So for example, if the stride is said to be 1, okay, so the entire box will now move to these 4 blocks. Okay, the entire box will now move to these 4 blocks, and it will look somewhat like this. Whereas if the entire stride was 2, okay, instead of 1, if the entire stride was 2, the box will move at this particular part, and it will be somewhat like this. Okay, and then it will make a computation on the same, and it will bring us a new block via that particular same computation. The computation does not changes, the computation remains the same, and we get a new box. Okay, and it's so on and so forth. It just like it can, so if this stride is true, then it will move, the next will go right over here. Okay, it will bring some other computation, it will store right over here, it will then move right over here, it will bring another computation right over here, and so on and so forth. If the stride was 1, in that particular case, it will have been a lot different. It will look somewhat like this. The entire convolutional layer would look, so this is the first box, then it will move right over here. Okay, so this will give you the second box, then it will move right over here. That is like this particular part. It will give you a third box, it will move right over here, yes, and so on and so forth. So it will give boxes like this to you. Okay, and these all contains the features that it determined from that entire thing. Okay, this is called as a convolutional layer. So as you are able to see in this particular picture right over here, so this particular convolutional unit was able to get the information from these all boxes. So these boxes right over here, if I'm highlighting it, these are the boxes that it made the computation on to get this particular box. So as you're able to see, one of the things that is very prevalent in this is the image is getting shorter and shorter. Okay, the original image is getting shorter and shorter. So if you are making a very deep like new network, okay, of many the convolutional layers, then going further on, at the end of the day, the image will become a single pixel, and then you cannot process it. Basically, there's nothing to process from a single pixel. So that is one of the challenges that were faced by the like different researchers. So like, let's see this. So for that, okay, for that, one of the main things that was introduced was this padding. Okay, so originally the entire picture is only this much. Okay, the entire picture is only this much. This is the original picture that was present. It is being padded. Okay, this entire picture is being padded by this zeros, arrays of zeros. Okay, this arrays of zeros has like padded it from all around. Why we are doing this? So that when you are applying the entire convolutional layer, the next thing that you are able to get from this, okay, would be the exact same size of the original image. Basic mathematics. When you are applying a convolutional layer of 3 by 3 on a particular image, okay, with stride 1, then it will get compressed from all sides by 1 unit. Okay, now if you pad the entire original image by an array of zeros and then apply the convolutional layer, then the new convolutional layer that is being formed is of the exact same size as the original image. The image is not getting shrunk down. The second biggest problem that was happening was, for example, just look at this. Okay, so this is a particular image. Okay, sorry. So this is a particular image. Okay, we are having this particular like unit of the entire convolutional layer. Okay, so it is looking at only this particular one. It has a size of 3 and it will move by 1 stride. Okay, this stride is actually 1. So the corner pixels that were present, they were not getting a lot of attention. So what is happening was, as you are able to see, the middle pixels, okay, these were getting repeatedly taken into consideration. Okay, so many number of times for each convolutional, these middle pixels was taken into consideration, whereas the corner pixel, for example A, was taken into consideration only once. For every like every 9 times the middle pixel was taken into consideration while making the convolutional layer, the corner pixel was taken only once into consideration. So even if there is a feature in that particular area in the corner of the picture that was not given a lot of priority while making the convolutional layer, so to change that as well, they introduce the padding. Okay, this also like helped with the padding, because now the pixel that is at the corner is not getting a lot of attention. Of course, it's zero, we have padded it, it's extra, we don't want it to get a lot of attention, and hence these corner pixels, these edge cases are getting lower value than the A. Now that is getting a higher value. Okay, so that is also something that helped with the entire case. So that is called as padding. Okay, this is a zero padding added to an image. So this is how it will actually look like. Okay, so moving further, filters. Now, like I've said, for example, this is the input image. Okay, input image, this is the convolutional layer. Okay, so this area that was present right over here, this particular area that it was looking at, it got converted into a single unit. Okay, into a single unit in the convolutional layer. So how did that mathematics happen? What was the calculation that took place? That calculation is called as filter. Okay, convolutional layer contains a different set of filters whose parameters needed to be learned. Okay, the height and weight of these filters are small than the input volume. Each filter is convoluted with the input volume to compute an activation map of the neurons. So very simple. Actually, what is happening is, for example, you are having this particular value, X, Y, Z, A, B, C, 9, A, B, C, D, E, F. Okay, so this is the input image. Okay, this entire thing, okay, of the input image is this. So the filter, what it will do is, it will look at what are the things that is important to them. Okay, so it will be a 3x3 filter. For example, this is 0 1 0 0 1 0 0 1 0. So this is the entire pixel. So when it is being computed, so what will be the output, you are asking? So the output will be something like y plus b plus e. Simple. Y plus b plus e. It's just like two matrices being multiplied, that's all. Okay, simple things are being done, not on a lot of scale. So different filters have different properties, how they can be used. Most of the filters are being used in such a way that they are able to find different like features. You'll see that right over here. So for example, if you are using like a particular filter, so the same filter needs to be applied on the entire picture to compute one feature map. Okay, one feature map needs one filter to go on the entire original image. So this is the original image. If we apply a horizontal filter to this particular image, as you are able to see, this will be the feature map that is being generated in the convolutional layer. Okay, as you are able to see, the horizontal lines that were present in the pictures have been exaggerated. Okay, we are able to see that predominantly. If the vertical filter was being applied, then the vertical lines will be exaggerated, that we'll be seeing in the feature map 1 predominantly. So this is how a a filter actually works. Okay, uh, of course, you do not have to define the filters manually. Instead, during the entire convolutional layer, it automatically learn the most useful feature filters for its tasks, and these layers will like above will then learn to combine them into more complex patterns. Okay, so you do not have to specify that, okay, use the horizontal filter or use the vertical filter. It is being learned by the algorithm itself. You don't have to do this. Okay, you can specify how many filters to use, so that is something that is in your hands. Okay, but still, like these filter feature map will then have some other kind of filter that is being gone over through to them to make a secondary convolutional layer, and in that convolutional layer, maybe like the shapes where there are circles are being like exaggerated more, like wherever there are circles, they are like bright spots. So that's the thing. Okay, this is how filters actually work. uh, Colored image, so many of you were asking like how do a color image work and all this kind of stuff. So think about a color image as three channels. Okay, so I will just change it to white. So each image which is colored, for example, this particular image, okay, it will have three components to it. Okay, this image is colored, for example, so it will have three layers, three matrices, three 2D matrices to it. Okay, the first one would be R, red. The second one would be green. okay, and the third one will be blue, R, G, and B. Okay, there will be 3 channels to it. Each channel, this is called as a channel. Okay, so there are 3 channels: R channel, green channel, and the blue channel. Okay, each channel is exactly like a matrix. Okay, just like we had seen for black and white pictures, it's 0 to 255. But instead of this time having the 0 to 255 to represent black to white, where 0 represented black and 255 represented white, here the 0 to 255 represents the intensity of the red color. 0 to 255 in this particular channel would represent the intensity of red for that particular pixel. The same pixel from the second channel will represent the intensity of green, and the same pixel in the third channel will represent the intensity of blue, and these when come together forms a unique color that you are able to see on your screen. So this is the concept of colored images. Of course, this is actually how, so this is a colored image, and this is how it will be interpreted by the computer. Each of these channels is actually a 2 by 2 matrix, and when combined together it represents a 3-dimensional matrix of a particular, so for example it is 28 by 28 pixels and 3 channels of depth. Okay, so each pixel is actually somewhat like this. Okay, you're having 28 by 28 pixels and 3 channels of depth. So this is how a colored image is being represented. Okay, so the same what we saw on how a particular convolutional layer 2, convolutional layer 1 is being represented in where is the color red? Convolutional layer 1, convolutional layer 2 is being represented in like a black and white image. For a red, like a colored image, this will how it the entire thing will be represented. It will be stacks and stacks of different feature map. Each of the feature maps, okay, we have already seen how a feature map is being generated. Okay, when we apply a particular filter over the image, okay, or the input, then we get a particular feature map. Okay, so each of these feature maps that are being generated is being generated by a different filter. Okay, so for example this particular feature map may be of like horizontal lines. Okay, the second map may be of vertical lines, the third map may be of the diagonal lines, the fourth map may be of the curved lines, and so on and so forth. And for each color as well, a different feature map will be established. Okay, these channels can also increase in some of the domains. For example, IV channel. Okay, so infrared channel, you can have an infrared channel, you can have a particular like radio channel, you can have a particular UV channel, and so on and so forth. So you can have as many channels as you want, but for a picture itself you are only having 3 channels: red, green, and blue. Okay, you can base it, some of them use hue as well for the channel, so that is a totally different concept, not going into that because that's, I will have to explain it a lot to you, you will not be able to understand. So keeping it very simple, this is how the entire thing will be represented. Extremely simple, nothing fancy, nothing tough. Okay, I've kept it extremely simple for you guys. Okay, now some of you were asking, sir, which laptop, what should I do? See, currently the state of computing is so good that you can even use a single like iPad or a tablet to do your entire work. Okay, like a laptop that has browser on it can do anything right now. Okay, that's the only thing. Like, if of course everyone cannot buy a MacBook, everyone cannot buy a computer with i7 16 gigs of RAM, everyone cannot buy a GPU Nvidia 360 380 380 super, or so on and so forth, or 390. Okay, everyone cannot do that. The best option if you are in a budget would be Chromebook. Okay, if you are still in a lot of budget, then take up a like entire laptop without any OS in it. Okay, no OS, that will like cost about 15,000 cheaper than a particular laptop with an OS in it, and install a distribution of Linux in that. Okay, that is something that you can do, that will bring the cost of the laptop, like a 15,000 discount is a very large discount actually. Okay, so that is something that you can do. Just ensure that whatever laptop that you are taking in, it has a good amount of RAM. Okay, if you want to do everything local, so for example, when we will be doing the project, okay, we'll be using collab. Okay, we will be using Google Colab, so that's an entirely done on the network itself, like on the browser itself. You can use a phone to make your entire model. You can even train your entire model using the phone itself. You do not even need a laptop. Then GitHub, Gitpod, and all these type of concepts are being coming up very recently, where you can even buy an entire system of i7 11th gen with the best RAM, with the best GPU on the cloud for less than 5 rupees a day. Okay, you need a browser and like keyboard and get started working on anything that you want on a very on the cloud itself. So these all things are also coming up. Most of them are free. So repel.it, okay, so that's an amazing platform where you can do entire like coding, programming, developing websites, developing even apps on the browser itself. You do not need anything. Okay, so that's also something. So just like CNNs are something that take up a lot of memory. Okay, when you're training them, they require a lot of RAM. So that's also something that you need to know. Okay, so another concept was of pooling layers. Okay, so what happens is usually the images that you use in your daily life. Okay, for example, a normal camera of your phone that takes up an image, it's usually of 4K quality. Okay, now this large image is really huge to process for your GPU. Like you have to process like 10,000 images, or like even 1 lakh images, or 1 million images. Each of 4K can take up a lot of space actually in your like entire RAM. You need like 32 gigs, 64 gigs of RAM to process, do some time like that kind of processing, and it will take up a lot of processing power as well. So to lower the entire computational cost of the network, usually you downscale the image. Like you will use an image of about like 512 pixels, or like 512 by 512 pixels, or like even a smaller like 250 258 by 258 pixels, or something like that. Not a very large pixel, 256 by 256. Okay, so this downscaling can be done using pooling layers. Okay, so what does a pooling layer does? It will take in the entire pixel. Okay, it's just a type of a filter itself, but instead of like having a very complicated, like each thing having its weight and everything, it just takes in the entire thing that is particularly present there. So for example, we are having max pool, so it will just take in the entire like 4 by 4 area where it had to pool, and then it will take up the maximum value from the four options and then put it in the next in the image that you are actually going to use. So this, like you are having a filter of size 2 by 2 and a stride of 2. Okay, so it moves 2 blocks ahead. Okay, so this is also something that you need to understand. Max pooling, an important concept. You are having max pool, min pool, average pool. As the name suggests, pool means like to collect together, and maximum, minimum, average means like the maximum of the entire pool, or the minimum of the entire pool, or the average of the entire pool. So this helps to downscale your image so that it can be used easily for the computation. Okay, so flattening, we have already discussed that. Like you are having your like pooled feature map. Okay, you put in the image, you make a particular pooled feature map, you compress the image actually, that is the pooled feature map, and then you flatten the entire pooled feature map. So this is how the flattening is actually done. So this is the entire different concepts that we are going to use to make our project. This is done. The theory is finished. From tomorrow, we'll be starting with Python hands-on coding. For the next 2 days, we'll be learning various different things that we'll be using, and for the entire project as well, and some of the important topics that I think is essential for everyone to know at the basic minimum that is required. No prerequisite required for the project. I've already told you that, like we never like have any prerequisite for the same. We'll just now bring on the entire so the attendance will be for 10 seconds on the screen. So whosoever wants to take a screenshot can do so. Okay, just take a screenshot for the same. It will be on the screen for the next like 20 seconds. Okay, it's gone. Just a second. Just take a screenshot and then we'll be moving forward. Okay, so for those who have not taken it, they can move back and then like take it again. I hope so. Okay, so yeah. So I will be like now, like I will answer the questions if you want. I'm just right over here. So we will be using collab, okay, for the entire session, because I can understand many people do not have mobile phones, many people like do not have like laptops. So we'll be using collab. It will be done on a browser. It can be done like we can use it on anywhere, like literally anywhere you can use it. Okay. Of course, for those people who want to get into like learning about different stuff, you can go to our page. Okay, Instagram page, the link is down in the below in the description. As you see, like we post about like interview questions, like what is a random walk, and their answers as well. These questions are being asked a lot of time in interviews right now for machine learning, Python, data science. So we also post a lot of different stuff like basic knowledge that you need. We also post projects and everything. So for example, let's see right over here. uh, we have some projects, I guess. Yeah, so build a random forest app in less than 10 lines of code, decision trees. Then like this comes included with the entire like theory and the entire code as well, so that you can easily make your own projects. So there are other projects as well, just like I'm not able to find them right now. But there are a lot of projects. For example, build an audiobook app in like less than 10 lines of code. So that's also something that was a good project for beginners. Just like it's not for like higher level people, just for beginners, so that you can easily understand the different ideologies. Also, like we post some relevant informations as well, so that you can easily able to see and understand that. So if you want, you can like follow us there, and we continuously post every single day. Okay. Should you explain zero padding and stride again, please? Okay, just try to understand this. Like, there's a picture, you are having a filter, you need to move the filter on the entire picture. Okay, so what do we mean by stride? How many pixels do you want to move the like filter with? Like, you want to move it by this much, you want to move it by 2 units, you want to move it by 4 units, and so on and so forth. So that is what an entire like stride is, like how much do you want to move the filter by. And the padding, that is zero padding, is basically like there is the entire picture is there, and the entire picture is being surrounded by zeros. Like you are adding layers like rows and columns around the entire image, and those are containing zeros. That's the entire concept of zero padding and strides. AR is not under computer vision. AR is a separate field of its own. The hidden layers are something that we need to make it. Like it's just like we'll see in the code itself. You just have to write how many neurons do you want in the hidden layer. That's all. Like I want 512 neurons. Done. The hidden layer is completed. Okay. The next bootcamp informations, you can find it on our LinkedIn page, on our Instagram page, on all the WhatsApp groups of Shape AI, on the Telegram channel. We regularly post about it. Any advice for CSE first year students? See, I don't know from which college you are from. Depending upon different colleges, different advices can be given. But a common advice would be to start learning. Okay, do not waste your time. You may feel that okay, I've like prepared for JEE mains for 2 years and so on and so forth. But do not waste any time. Get started. Start learning new technologies. Uh, See, we have cracked various companies. Like we are having Parag Mittal from Microsoft, who is one of the co-founders at Shape AI. We are having Rahul Halalka, who is one of the instructors at Shape AI, who is currently a data analyst intern at Goldman Sachs. We are being joined by people from Google, from American Express, from Visa, and so on and so forth. So we can really guide you. Actually, we can provide a proper guidance to people, and that is what Shape AI wants to offer to the entire population. That is something that is really missing in India and abroad as well, basically. Yeah, the data analyst internship is enough to apply for jobs, because we feel that any student should have the necessary skills as well as the necessary like training and the necessary like experience. That is what Shape tries to offer. Okay, so we'll meet tomorrow, guys. I'm also a bit tired right now. We'll start with Python from tomorrow. Please be on time, because tomorrow I will not be waiting. There's a lot I need to cover in Python in just 2 days. And of course, major number of students who are coming to the entire bootcamp do not know Python itself. So I have to take that into account as well. So let's get started from tomorrow, and hope we will have an amazing like seminar and everything.